She took him to a doctor's appointment and then she was like, can I treat him to lunch? And I think my sister, and she took my son to a doctor's appointment. But it. I'll just drink my water. Okay. So last class, y'all did the common base solving. You don't need that today. You actually don't even really need a calculator today. But you'll need one on Thursday when we kind of put these two lessons together. So for today, we're going to learn what a logarithm is. Okay. So last class, you did the exponential parent function 2 to the x. And then if you remember, it has a horizontal asymptote that goes flat across like this, which means that you cannot touch that line. Y equals 0. Okay, so I'm going to put here, this is an HA. Okay, then remember that because I now can't touch the x-axis, okay, I can't go through the origin, then I'm going to go through one box above the origin. And then remember that your graph goes down on this side towards the line and then up on this side. Okay, and we're really just kind of sketching the shape. You don't have to hit all the exact points. What was the domain for this graph? Do you remember? All real numbers is correct. What about the range? What's the lowest that it can go? 0, and the highest it can go is infinity. Also remember that on the 0, we gave it a parentheses because I get closer and closer and closer to 0. But remember, I'm not actually gonna like get there because I can't touch that line. Okay, so the inverse of an exponential is called a logarithm. Okay, and when I say inverse, that's like things that cross out with each other. So like plus and minus, those are inverse operations. Squared and square root, those are inverse operations. I can't think of any more, but there are more. Cube and cubic root, stuff like that. Okay. So for a logarithm, you're going to write down y equals log x. Okay, log is short for logarithm. And then I want you to remember that when you do an inverse, the domain and range of those are reversed. So rather than my asymptote being y equals 0, now my asymptote is going to be x equals 0, which means that it's going to run this way instead of across. So for the exponential parent function, you have a horizontal asymptote. Okay, for a logarithmic function, you have a vertical asymptote. So I'm going to label that VA for vertical asymptote. Okay, then remember that because I can't pass through the origin, for the exponential, do you remember that I did one box up? Now you're going to do one box to the side. So go one box to the side. And then your graph is going to go up and away, down and towards. Like that. So this side is going to get closer and closer and closer to that line that you drew. Okay, and then this side is going to go away on this side. Abby, you can just sit over here for now. Okay, your domain, let's talk about it. Will it be all real numbers? No, because it can only go back till it hits this line. What x is that? 0. So it'd be 0 to infinity. Okay, now also remember, why do I give 0 a parentheses? Because it's not gonna actually touch 0. It's gonna get close to it, but it can't cross. Okay, then for my range, I have one side pointed down, one side pointed up. What's my range gonna be? All real numbers. And now will you just make an observation real quick? Do you see that the domain and range for the exponent are just reversed for the logarithm? That my domain was all real numbers, now my range is all real numbers. My domain was 0 to infinity, now that's my range. Okay, so now let's look at number 1 and 2. Let's just kind of take a look at how we move these graphs around. So I have a -3 in parentheses with the x. Which way are we shifting? Okay, normally a minus would be backwards, but if it's with the x, what do I do? Okay, remember, you do not trust your x, as I always used to say. Okay, remember, if it's with the x, you don't trust your x, okay? Don't do that. So go to the right. Okay, then the +2, you're gonna go up 2. So go to the right, 1, 2, 3, up 2. Then through that dot, you're gonna draw your new vertical asymptote. Okay, so it's gonna cut through like this. And it would be x equals what number? 3. Then remember that for exponentials, I place my dot 1 dot above the origin. But for logarithms, I'm going to place it 1 dot to the right. So where that origin spot is, you're going to now go 1 dot to the side of that. And then remember, this is your shape right here. It's going to go down really close to the line. And then up and away from the line. Okay, then hopefully you could find your domain and your range, just like we did on the other. Take a look at number 2. Which way are we moving if there's a +5?
Right.
Left, and -1 will be down, so I'll go left 5, down 1. Remember, in that spot, I'm going to draw in my vertical asymptote. What will that number go through? X equals what? -5. And then from there, I'm going to place my dot 1 to the side, and then I'm going to draw in my shape, just like we did with exponentials. So 1 to the side, up and away, down and towards. Okay. And then I don't want to do domain and range for both of those, but let's just do it for the second one. What will the domain be? How far to the left can my graph go? All the way back to -5. But on the other side, we know that it can go on till infinity. For my range, what would it be? All real numbers. Because remember, your lowest point is down to -infinity. Your highest point is up to positive. Okay? All right, turn the page. Okay, so graphing these should be pretty easy. Okay, the other thing is logs have a bunch of weird properties. Okay, so they're really only 3, so there's not a bunch, but they're kind of weird. So just go with it. Okay. For logs, if you have the log of 2 things that are multiplied, okay, let's say A times B. You can split those up into separate logs using addition. Oliver, can you put your computer up? So that's going to split up into log A plus log B. Now, if multiplication can be split by addition, what do you guess division can be split by? Subtraction, very good. So your second rule is going to be that log of A divided by B is going to be log A minus log B. So multiplication splits into addition, okay, and division splits into subtraction. All right, so let's do some examples. Okay, number 3, I have the log of 8x. Right now, that is 8 multiplied by x. So when I split them each into their own log, will I use addition or subtraction? So it'll be log 8 plus log x. Obviously, these get harder, but that would be your answer. Question number 4, you have 8 over X, that means 8 divided by X. And if 8 is divided by X, how can I split them into their own logs? Subtract, so log 8 minus log X. Okay, take a look at number 5. I want log of 2x over y. Let's break down what that operation is. That means that you're doing 2 times x and then divided by y. And remember that when you are expanding, that's what this is called. Everybody wants their own log. Nobody wants to share. So what that means is that your 2 is going to get its own log. So is x, so is y. So let's start with 2 and x. I'll have the log of 2 plus the log of x, because those were multiplied together. Then when I get to the y was divided, so I'll use a subtraction. It'd be like that. Okay, there's one more rule we have to learn. Okay, the last rule is going to be your exponent log property. So I want you to write that if you have a log of a up to the nth power. Okay, there is a rule for logs that n can just drop down to the front and become n log a. The n can drop down to the front and become n log a. So let's take a look at number 6. I have the log of 2xy5. What is the operation between the 2, the x, and the y? Is it multiplication or division? Multiplication. That's 2 times x times y5. So I'm going to have, remember, I'm splitting up by plus when it's multiplication. So it'll be log 2 plus log x plus log y5. Okay, then this rule comes into play. That fully expanded form, your exponent from the top is going to drop down to the front of that log, which means that this 5 is going to drop down to the front and make it a 5 log y. So here's your final answer. Log 2 plus log x plus my 5 drops to the front, log y. Okay, and that would be considered expanded form. Okay, where nobody's sharing a log. Not even the y and the 5 are sharing the log together. The 5 moves to the front so that they're separate. Okay, let's take a look at number 7. What is the operation between x, y, and z? Are they multiplied or divided? That's x3 multiply y multiply z to the 7. So when I split, multiplication splits by addition. So it's going to be log x3 plus log y plus log z to the 7. Okay, then after you separate everybody into their own log, any exponents that you have up top, you can drop those down to the front. So what numbers am I moving? 3, 6. Okay, the 3 is now going to be a 3 log x. Log y is going to stay the same because it doesn't have an exponent. And then my 7 will come down to be a 7 log z. Okay. Let's take a look at number 8. Number 8, I have a 2a cubed divided by a 7b to the 5th. Okay, the way that that breaks down is your 2 is multiplied by a3, and then it's divided by 7 and divided by b5. Okay, now think about why that is. Okay, if both of, and this is where sometimes people will be like, well, the 7 and the b are multiplied. Yeah, they're multiplied with each other, but then what do they both do? They get divided. So think about if it's on the bottom, it's division. So when I split this up, my log 2 is going to add or subtract with my log a. Add, but then add or subtract with my log 7. minus, and then minus. So you're gonna have log 2 plus log A3 minus log 7 minus log B5. Okay, then to not have to rewrite the whole thing, I'm just gonna drop the 3 down to the front and cross it out. Drop the 5 down to the front and cross it out. So that would be your answer. Okay, but these numbers, remember, those exponents can just drop down to the front. Okay, and then I guess I am, just because I'm gonna rewrite it. So log 2 plus 3 log A minus log 7 minus 5 log B. Okay, you don't have to do that though. All right, go ahead and turn to the next page. All right, the last thing we have to cover for you to start your practice is specific types of roots where they're in a square root. So if you look up at the top, okay, the square root of B is equal to B to the 1/2. A cubic root of B is equal to B to the 1/3. So basically, whatever number is in this elbow, okay, of this root, that's the type of fraction you would use. So for example, if you had a 5th root of B, you could write that as B to the 1/5. Okay, Oliver, we're almost done. Let's get it up, please. So now take a look at number 10. I have log 7 root x. How are the 7 and the root x combined right now? Is it multiplication or division? So this is 7 times root x. Then when I split them up, I'm going to do log 7 plus log root x. Then from there, I'm going to say, wait, a square root is really what power? We just wrote it down here. A 1/2 power. So I'm going to cross out the root and change it to a 1/2. So that then, based on your exponent property, that 1/2 can drop down to the front. So now your final answer is going to be log 7 plus 1/2 log x. Kind of weird, but follows all the same properties that we did on the other page. Take a look at number 11. I have a log 15 root A over B cubed. Well, then that's going to be 15 multiplied by root A and then divided by B3. And so then remember, multiplication splits into addition. Anything divided becomes subtracted. So it would be log 15 plus or minus log root A plus log root A plus or minus log B minus log B3. Okay, and then when I'm moving my exponents down, I just want to be aware that a square root is really what power? A 1/2. So I'm going to cross out my root, change it to a 1/2, and then I'll drop it down to the front just like I would with my 3. So your final answer on that one would be log 15 plus 1/2 log A minus 3 log B. Okay. Number 12. What would the exponent be for the cubic root B on the bottom? You remember what power we use on a cubic root? 1/3. So for this one, I'm just going to write the answer out since we did one kind of similar. It'd be log 5 plus log A. And now look, instead of putting a squared here, where am I going to put it instead? In the front. Okay, then minus my log for my B. But if it was in a cubic root, what do I put in the front? A 1/3. Okay, kind of see if that makes sense. Most of these, that's why I said you don't really need a calculator. You can just do it in your head. Okay, go down to number 13 and 14. Okay, number 13 is all multiplication. we have a 10 multiplied by a root x to the 5th, and then multiplied by a cubic root y to the 4th. So if all three of them are times, then when I split them up, I'm going to put pluses in between. So I'm going to have log 10 plus log root x to the 5 plus log cubic root y to the 4. Okay, then if you already have a power here, right? So my x, it already has a 5 up top. What is a square root the same as? A 1/2, then I'm just gonna half the 5. So it's gonna look like this. Cross your square root out. I know that a square root is really a half, so I'm gonna cut the 5 in half. Same thing for the other one. Cubic root y is really what power? A 1/3. Then I'm gonna cross out the cubic root and put the 3rd on the 4. That way, this is kind of like a package that you can move to the front together. So your final answer would be log 10 plus 5/2 log x plus 4/3 log y. Make sense? Not too bad? Okay, last one, number 14. Okay, we have the cubic root of log 2 times c times d4. So first thing I want to do is split those guys up. So it's going to be log 2 plus log c plus log d. Okay, but then all of those are inside what? A cubic root, right? So I want to make sure that when I apply my cubic root, that I apply it to everybody. And what is a cubic root the same as? What fraction power?
3rd.
So I'm going to put a 3rd here, a 3rd here. And then if there's already a 4, I'll just put the 3rd on the 4. Does that make sense? So if everybody's in the root together, make sure that you apply that to everybody on the inside. Okay, then we'll just drop those numbers down and then you're fine. So it'd be a 3rd log 2 plus a 3rd log c plus 4/3 log d.
Why is it up?
Good?
Yeah.
Okay. Now, the other half of these notes, if you'll just turn the page, it's gonna be, instead of you starting with 1 log and you're splitting it up, you're gonna start with a bunch of logs that are split up and you're gonna put them back together. So if you finish the first half of the homework and you wanna go on and just try it backwards, that's fine. But we'll do the notes in probably like 15 minutes on that last page, okay? So pull out your Chromebooks. And you're doing the first half of your homework for where it says expand. Okay, for where it says expand. Okay, you should be able to see it now. Okay, let's just do the first one together, but I feel like you could do it even without my help. Okay, how are the 8 and the x squared combined? Are they multiplied or divided? Multiplied, then how do I split them up? Plus or minus? Plus. So this is going to be, type it into your thing, log 8 plus. Okay, if you want to use the keyboard, you can. There's a little math keyboard up here at the top. Okay, and then I'm gonna do log x squared, or will I? Where will I put the 2? In the front, you get it? Okay, so it might seem like, oh my gosh, it's a million questions, but remember, you're just typing them out separately. You're not actually solving anything today. Okay? I think any of y'all need, check. No, no. No,
You have to log.
okay, will you pass one again? Yeah. Uh-huh. Any of y'all need set of paper? Any of y'all need pen and paper? Okay. Don't think so.
We need, we need
Yeah, you can put the bracket, but it'll kind of write it out as well. And then was that what you were saying whenever, I thought you had said something like. Was it about a bracket?
yes, yeah.
Yeah, you can put it, but since you didn't have to put it on those math, you only have to put the bracket if there's multiple things inside.
Okay.
So like when you're condensing them into one, you'll have to put the bracket.
Okay.
Yes, sir. Remember that since y is in the bottom, it needs to be minus log y. Because even though the y and the z are multiplied with each other, they're both divided if they're in the bottom. So you need to have a minus under log y. Yes, ma'am. You could do all of the expandings. The expandings level 2 are just gonna have some of the roots in them where you have to put like a 1.5 in the front. What was your question? You got it? Okay. It should be log 9
Oh, wow.
plus 5 log x. There you go. Uh-huh. Yes, can you wait till we finish the notes? We're about to go. Is it an emergency? If it is, you can go. Okay. All right, go ahead and turn to the last page. We should be able to run through this pretty quickly. I don't want to rush you on the homework, but I also don't want to like make the notes take forever either. So at the top, you're going to do the same 3 properties, but you're going to do them backwards. So now, if you have a log of A plus a log of B, you're going to combine them back to log AB together. But if they were originally added, when you squish them into the same log, you're going to use multiplication to make them share the log. Okay, if it's log A minus log B, how will I put them back into the same log? Division, so it would be log A divide by B. Now, one thing that is important on this rule make sure that the A ends up on the top, and what you're minusing is the one that ends up on the bottom. Okay, then last one, if you have an n log A, remember that the n can now jump back up to be an exponent. But it's literally the same rules. You're just doing them essentially like in the reverse order, basically. Okay, so let's take a look at, let's start with number 1. So I'm looking at number 1. Before I combine them into the same log, I want to move any front numbers up. What number is a front number that I'm going to move up? 7, so drop it and put it up top. Then I would say, okay, my 3 and my x7 are originally, oh, thanks. They're originally added. So when I combine them back together, it'll be 3 times x7. Okay, let's go down to number 3. We'll skip number 2. Okay, first thing I'm looking for is any numbers I need to push up. What numbers am I going to push up on number 3? Okay, I have a 5 that can jump up on the y. I have a 10 that can jump up on the x. Then from there, I want to combine them all back into the same log. It's going to be 14 times x10 divided by y5. Okay, does that make sense? Okay. Now take a look at the next one. If you have parentheses, you need to be sure to distribute the parentheses before you do anything else. So for example, here I have a log x, but then this minus on the outside needs to go into both of these. So my minus is now on the 5 log a. And what's minus on a -3? Now that's a +3 log b. Okay, so once I've distributed those parentheses in, then I'm going to pull all my front numbers up and then put everybody back into the same log. So my a is now an a to the 5. My b is now a b to the 3. And then when I condense them back into the same log, where is the x going to go, top or bottom? Where is the a5 going to go? Bottom, because it has a what in front? A minus. And where's the b going to go? Top. Okay, because it ended up being a plus. So you'd have an xb3 over an a5. Okay. Take a look at number 5. What am I going to have to distribute on that question prior to moving anything? The 4. So I'm going to have 4 times log x is now going to be a 4 log x. And then for my next one, 4 times 8 means what number's in the front there now? 32 log y, because that's what we would get if we did the 4 times the 8. Okay, should I also multiply it times the -2? No, so 2 log z. And then from there, I'm going to push those exponents up, then combine them back into 1. So this is an x to the 4, y to the 32, z to the squared. And then when we put them back together, anything that has a plus is going to stay on the top. Anything with a minus is going to go into the bottom of the fraction. So it'll be like this, log x4, y32, z squared, like that. Okay, last 2 questions, almost done. Take a look at number 9. On the outside, I see that I have a 1/2. If there are parentheses, okay, you should not do any combining until you've pushed that 1/2 into both terms. So what is 1/2 times 6 log a? 1/2 of 6 is 3 log a. And then I'll do 1/2 times my log b. Just makes it basically a 1/2 log b. Okay, now that my parentheses are gone, I can move my front numbers up, then squish them together into the same block. So my 3 is gonna go to become an A cubed. My 1/2 is gonna go up top on the B. And because these are originally added together, how will I combine them? Multiplication or division? So it'll be A3B to the half. Okay, however, we know that a 1/2 power is really what, the same as what? A square root, very good. So my final answer would be A3 square root B. And if you want to fill out up here at the top, B to the half is a square root B. B to the 1/3 is a cubic root B. And I think we know where those are in the keyboard now, but if you don't, just raise your hand and I'll show you. Okay, number 10, can I move numbers up right now? Not if they're parentheses. So I have a 1/3 on the outside, I'm gonna have to multiply that in. What is a third times 12 log A? Very good, it is a 4. Remember that a third just means divide by 3. So if I divide by 3 on 12, that gives me the 4. So 4 log A minus a third log B minus a half log C. Then from there, I'm gonna pull those front numbers up and then squish them all back together into the same log. So this is now an A4, this is a B to the 3rd, this is a C to the half. And then when I combine, I know I'm gonna have a fraction because I see some minuses. Where will the A4 go, top or bottom? A4 will be on top, where will the B go? Bottom, and if it's a third power, what is that the same as? Cubic root, very good. And then my C, where will it go, top or bottom? Bottom, and it'll be under what type of root? Square root. And remember, for a square root, there's an understood 2 in the elbow that you don't have to write it. Okay? So that would be your answer. When you do your condensed problems, the log part is already typed for you, that you're just typing in this middle part. Okay? If you need help with it though, let me know. Y'all have lunch in about 15 minutes.